Hey, it's good to see everyone again today. So this is going to be our budget constraint part 1 video. So it's just a very simple introduction to budget constraints. I'm going to try and keep the video to 5 minutes or less. Let's see how well I do. I don't have a very good track record with timing. And if you find this rudimentary, feel free to skip it. Today is going to be really simple. So what is a budget constraint? A budget constraint is an abstract concept that we use in economics to capture the idea that we are generally constrained by a limited amount of resources. So if you're a farmer, then the constraint that matters to you is mostly your time and the amount of available land and maybe some seed. If you're a student at Denison and your tuition's already been paid for through a scholarship or financial aid or your parents, then the main constraint on your life is your time and your effort. And how you choose to allocate your time and effort are the daily decisions that you have to make. But as you all already know, especially during finals week, there's only 24 hours in a day. But just to keep things simple, we're going to abstract away from specifics and just think of money as the main constraint that we have to deal with on a daily basis. Because to some extent, once you're not a student, time is money. And in a lot of situations, it's appropriate to model money as the main constraint. So what exactly is being constrained? Well, stuff. So when we think of a monetary budget constraint, the main thing that's being constrained is what you can purchase in a given time period. So we usually think of budget constraints as related to a specific unit of time. So for example, your monthly food budget, your monthly rent budget, your weekly snack budget, if any of you are familiar with the concept of budgeting appropriately. Maybe you learn that eventually. So in reality, you buy a ton of stuff. You have some amount of money and you buy a ton of stuff. But that's a little bit complicated. Let's simplify the world to a two-dimensional universe where there's just two goods that you're buying during a given period of time, and you have a set amount of money that is available to you during that period of time, just to keep things simple and tractable. Okay, so let's consider an example. So we think of, first we're using the concept of a consumption bundle. So a consumption bundle is an ordered pair denoting the quantity purchased of two different goods. So during a given week, maybe the only goods that you're considering purchasing is bread and cheese. Or we could alternatively think of apples and bananas, or you can think of coffee and rice. We're just simplifying the world to two goods and thinking of them as an ordered pair. Let X be the quantity of good 1, and let Y be the quantity purchased of good 2. So when I say ordered pair, what I mean is this. I mean, we might purchase 10 units of good 1, and we might purchase 20 units of good 2. So good 1 is X, the amount of X that you're buying, and 20 is the amount of good Y that you're buying. So it's an ordered pair, right, with X first and then Y second. And then let PX denote the price of good 1, the price of X, and let PY denote the price of good 2, the price of Y. And then lastly, let B denote your total budget constraint for a given unit of time. So B, for example, might be $100 to spend on good X and good Y in a given week. And good X and good Y are both things that you need and like bread and cheese, as an example. So continuing with our example, let's say that the price of good X, price of X, is something easy, $10 a unit. So we set it to 10. Let's see, is equal to 10. And let's set the price of good Y equal to 20. Let's say, keeping up with what we just said, our total budget is $100 for the month. And we have to decide how to distribute our money between good X and good Y. So if we buy, let's say an extreme example. Let's say that you decide to not buy any of good Y because it's too expensive and you're going to spend all your money on good X. Well, you're going to end up spending $100 divided by 10 because it costs $10 per unit. You're going to end up buying 10 units of good X and 0 units of good Y, which yields the ordered pair of 10 units of good X and 0 units of good Y. Okay. So it's a little bit of an extreme example, but it's affordable. You can afford it, and that's one possible choice. Okay. Another simple example is, let's say we keep the same prices, still have the same budget, but you decide to purchase 0 units of good X. How many units of good Y could you afford? Well, doing some very simple math, if you have $100 and each unit of good Y costs $20 per unit, you could at maximum afford to purchase 5 units of good Y, which yields you the consumption bundle of 0 units of good X and 5 units of good Y. Simple, right? And lastly, let's say you wanted to split your consumption between X and Y. Well, you could theoretically buy 4 units of good X, spend $40 on good X, which leaves you $60 to spend on good Y, which means you could at maximum afford 3 units of good Y, which yields the ordered pair of 4 units of good X, 3 units of good Y. So we call that the consumption bundle that is affordable. So if a consumption bundle is affordable, meaning you can afford to buy all those goods given your budget constraint, then we say it's feasible. We say it's part of your feasible set or your affordable set, which are the concepts we will discuss in the next mini lecture. All right, see you guys in the next video.